Yeah, I'm going to get started. First of all, thank you guys very much. Actually, I hope to we start this. We call it NASA Earth Exchange Workshop and called Hands-On Series. I'm going to talk about why we call it Hands-On Series a little bit later. But the topic today I'm going to talk about is climate downscaling with NEX Sandbox. So, of course, with many. So, with many contributions from my colleagues here, from the NEX team. All right. So this is outline. So basically, I'll go very briefly about why we're talking about climate downscaling for NEX, right? And some background on what is climate downscaling. I'll go very briefly. And then we're talking about how you actually use an NEX Sandbox to do climate downscaling. And I'll give you a very step-by-step hands-on example how to do that. And by the end of the class or workshop, I'll give you some exercise to do and also some discussion topics to think about it. All right. So now, why is we're talking about climate downscaling here? Well, NEX or NASA Earth Exchange were actually founded by NASA as an enabling tool to support a project called National Climate Assessment. So we know that climate is changing. Very, very confident. The scientists community or scientific community are very confident climate is changing. Now, for stakeholders, for decision makers, they want to know what to do in terms of climate changing, right? The scenarios. So what we predict is we run climate models for 100 years. We run many models, but the problem is the models run at coarse resolution. The best, the state of art today is about 1 degree by 1 degree. It's at 100 kilometers level. So for that coarse resolution, the decision makers or city planner, it's going to be hard for them to use that information because it's coarse for their city or watershed resources. Yeah. Another problem of climate model is our model are not perfect. So that means our model actually they're biasing model outputs. So that bias needs to be taken care of too, right? So simply put, climate downscaling is just a way we're trying to make the GCM output to a higher resolution. At the same time, we're trying to remove the bias, so make it more suitable for decision makers or people to use. Let's say just generally our users to use. Right. For NEX, we're actually a lot more because we're actually it's a collaborative platform. So we actually do long-term satellite data analysis. We also do use information from climate to model impact, how climate change is going to impact our society, water use, public health, you name it, agriculture, things like that. And we're actually capture workflow and basically store them on our platform. So once you have the new data coming, we can repeat it again to do it as a circle. So that's basic idea of how NEX uses it for national climate assessment. Right. So in the past few years, actually, we generated several big data sets based on 75 GCM outputs. These are, like we generate DCP30, which is just for US monthly data at very high resolution, about 30 arcsecond, which is about 800 meter resolution. We use a sample of 34 models, things like that. So basically generate about 30 terabytes for this one data. And GDDP is global, but it's daily at a coarser resolution. Again, it's a lot of model, a lot of data, and 20, 30 terabytes. These are generated by our group. And these two, Loka is done by Dave Pierce from Scripps. It's a very good data set. Also uses a new algorithm called localized construct analogs. So, and this one is generated by Edmar, called the bias corrected construct analogs. So different algorithms, but they also run the algorithm on NEX. So basically, we supported many community production of downscale datasets. So today we're going to actually talk about some basic ideas behind the generation of algorithm to generate these datasets. All right. Now, what is give you some theoretical background of climate downscaling. So there are, as I said, with downscaling, it's just take GCM outputs, trying to interpolate into higher resolution and remove the bias, right? So there are actually many online resources talking about this process, like a theory and some basic idea of algorithms. This one is from Lawrence Livermore. This is a very good website. You can go there. They actually have tutorial, have the basic description of what they call BCSD algorithm. So here's another one. This is actually from a few years ago, a workshop we call National Climate Prediction Projection Platform called ECPP. They have organized a workshop in Boulder, I think, focused on how we actually evaluate different downscale projects. That was in 2013, 3 years ago. But anyway, it's still very good material there. Very good presentation, so they have a video there you can check later on. Here is it is actually an online course training process by I don't know how to pronounce this, MedED or CoMed. MedED it's an online site sponsored by, I think it's Yokar, to provide maybe meteorology education online training. But they actually also provide very good packaging for downscaling climate data. So many of these resources actually go into the US Climate Resilience Toolkit. So this is sponsored by, I think, the White House or the Obama administration. So they have this climate resilience initiative, something like that. So they start this website. Anyway, so you can find many of the tools here. Some of the website actually hosts the data sets generated from NEX, like the climate data.us. Anyway, so if you go to this website, you can learn a lot about the background, the theoretical, theorem or the information about downscaling. But we feel like, from NEX point of view, we feel like there's no place you can actually. No other platform give you the data, give you an algorithm, actually let you to play with the data. What I mean is the hands-on experience. So that's why we think NEX maybe can contribute a little bit more to that aspect. Many things, you read a paper, you read, book, the theories, make sense, a lot of sense to you, but unless you start to do it, you feel, oh, this is difficult. And a lot of times it's the details are actually are very important, right? If you detrain the data wrong way, and it doesn't make sense, right? So that's why we think about actually organize this workshop, focus on hands-on experiences. So we're going to provide access and the code to the data sets here from NEX. We're going to talk about how to access and analyze these data sets from NEX Sandbox, and maybe from Amazon Web Services, AWS. We did a few years back, but we're going to do it again. And Google Earth Engine. Sean is going to talk about Google Earth Engine. And we have other people to talk about other platforms like the Planet OS. Later on, maybe we're talking about Microsoft Azure or some other platform. We're going to actually, in the end, we're going to host our code or some data on GitHub, so people can actually just directly download to their laptop to play with. Of course, for the big data, like I mentioned, like 30, 20 terabytes of data, you cannot download to your laptop, so you have to use something like AWS or our NEX. But that's later on. If you feel comfortable, you can welcome to join us. All right. So the sandbox is basically a cluster built by our NEX team, just to as the name, it's a sandbox for our user community to play with, to test some ideas. Right. So in order to get the sandbox account, I'm not actually an expert to do this, but let's talk very briefly. You need to go to our website, web portal, nex.nasa.gov. And first, you need to register an account for a web portal. If you're associated with NASA, which is make it easier, but if you don't, you have to use some OpenID like Google, Gmail, or whatever they accept. So, and then you go to resources and click on Sandbox, and it will bring you to some forms. Basically, it says how can you actually get the Sandbox account. Basically, you have to complete some request form and then send it to NASA people for approval. So sometimes this is actually quite easy. It's not takes like time about 1 week or two. So relatively easier. Once you have an account, you can actually click on those links about how can you actually log into the sandbox and what you need to pay attention to, how to use it. Right? As I said, it's a Linux box cluster, about 96 cores, tons of storage, a lot of maybe hundreds of terabytes storage, a lot of data there. So anyway, so it's a nice setup to play with, and it's free. Right. Now, so